Hey guys, welcome back to AlgoYogi. We are doing linked list series, and next problem in the list is design browser history. So we're gonna check out your browser history. Okay, you know what? Nobody wants to share that. I don't want to share my browser history. Well, okay, it's a design problem. You have a browser of one tab where you start on the home page, and you can visit another URL, get back in the history number of steps, or move forward in the history number of steps. So it's really simple. We're gonna have a current page, and then we can visit next page, and it's just one page. We don't have like just the number of tabs, just like here. This is one tab, this is another tab. That's not how you have it. You have just one tab, and this is the URL, and we keep visiting onto the next page or URL, and then we can also come back. So we're going to implement these functions. First is browser history. That's like basically initializer, that's our class. And then we have visit. So we're going to move forward to the next URL, and that will become our current URL. Then we have move back the number of steps, because you went some certain number of steps into the history, then you need to come back. You also got to check, like those steps could be more than the URLs you have visited so far, and we got to take care of that, and that to forward or backward both. All right, so I think there is not really to explain on this, but I will still just have it over here, show you guys like what we're actually gonna do. So we're gonna have like our home page, and we're going to call it current pointer. So current will be pointing to, we're going to have this called like home page URL, and we're going to use a doubly linked list. So it will point its next to none, and it will point its prev to none, and at the same time we are pointing our cur to cur over here. All right, then in the visit section, the visit method, if I'm visiting some page, then what I want to do is I will create that URL. So that will take URL value, and it will point its current and previous pointer will be to my cur, and then next will be none, and then I will move my current from here. I will take it from here, and I will point my current to this URL. So that will become my cur, and again, and home pages next will be set to this page. All right, that's it. And then if we are adding in the back, basically we are backing out. So this is what we have done in the visit. Then we're gonna back at the same time. Like what we will do is basically just move a step backward, move our current pointer to back, that the number of steps that it will provide us, that is it, this number of steps we will move forward. But we will check if we have that many URLs in the previous history that we have visited. And same we're gonna do it with the forward, check the steps and keep moving it backward. And since it's a doubly linked list, we're gonna have these current like next and previous pointers, so I don't think there will be any issue visiting current and previous, next and previous nodes in our list. So let's start writing our solutions. I'm gonna have it move it this way so that we have nice and sexy looking code right here. So first thing first, we will have a list node created. So let's create that. It's a linked list problem, but we are not given over here, since it's not like something algorithm problem. It's a design problem. You got to design everything by yourself. So we're gonna have something called list node class, and we will have our constructor. So that's how you do it. It's gonna take self, it's gonna take a value, it's gonna take our prev. Initially it will be pointing to none, and then it's going to take our next, will be pointing to also none. So if we are not providing these, we don't have to. But let's say if we're creating like a current pointer or head, you can say, then we don't have to provide previous and next. We can just say simply give the value, and next and previous, they will be pointing to none. That's what should happen. Now self.value would be, oh my god, value would be just val, self.prev would be prev, self.next would be next. All right, now in my constructor for the browser history, I want to create my current pointer where I'll be pointing to. So I'll just say self.cur, and that's pointing to list node, and that is taking home page. All right, that's it. And as I said initially, when we are creating this node, it will have previous and next pointing to none, so we don't care about that. Now let's visit a node. So how are we going to visit it? We got to first create that node, right? So self.cur.next, I'm setting the next here, and I'm setting my next to the list node that it's a new list node with URL as the value, and let's set its previous to current pointer. So self.cur would become its previous node. Next we are setting it to itself, and its next would be basically none. That's it. Then we gotta move our current pointer to basically its next. So self.cur would be self.cur.next. You see, like I want to move to this new URL that I'm just visiting, so which I created over here. This is the value that I'm sending as prev node value. So this will get set over here into this node. But remember, if I'm not sending anything as next, it will be set as none, which we need to, because it's a new node. Now we gotta go back. So I'm gonna have while cur dot prev, I'm going back, that's valid, and steps, I'm going to reduce down the steps. Steps are greater than 0. Then what I'm going to do, I'm going to reduce the number of steps, but at the same time I will move current to, and I shouldn't write it like this. I should have it, since it's a class level variable, I gotta refer it by self keyword. So self.cur self.cur.prev, and steps reduced by 1, and then at the end this needs to return the value wherever it has reached. So return self.cur.value, and we're gonna do the same thing for going forward, but just remember, oh my god, just remember, this time we're reducing the steps, but we're checking for the next pointer, and we are returning the value just like that. So, and this is going to previous, this is going forward, and I think so current is just being sent forward. All right, then let's zoom out and test it out. Did I write something somewhere? Okay, so I'm not just zooming out by myself, so I gotta use click. All right, let's run it. We have some error, and that's some mismatched index because I copied it, and what we really need to do is just move a little forward, and I think that's it. Alright, this runs on the example. Let's submit it. Awesome, pretty efficient. Let's talk about the time complexity. So it's a design problem. We're gonna talk about it at individual level. So when we are visiting something that's happening in big of constant time, so this is big of 1, and that's not how you comment in coming from TypeScript. So it's JavaScript or TypeScript, same thing, but okay. And then we are going backwards, so that depends on the number of steps, and also it could be just called worst case big of n. Same thing with the forward. Time complexity I'm talking about, space complexity depends on the entire class, and that's basically we are storing a doubly linked list. So that's also space would be big of n for everything. All right, so that's at the class level. I'm talking about the these method level. So, and this will also be big of n. All right, capital N. Let's go back to AlgoYogi, mark this problem solved, and we are making a good progress. I think this problem set got mixed, but I'm gonna refresh it. And all right, oh, this just got mixed. But anyway, I'll make sure that it's anyway. I don't care about this. See you guys later. Bye bye.